All right, today, inshallah, we will start. Just let me admit this, your friends. Today we going to start the new chapter, chapter number 10. And just let me change the date here. So I'm not confused with you. Let's see first. Okay, so today we will start with a new chapter, which is what we call chapter number 10. Chapter number 6. All right. The name of the chapter is an exponent, radicals, polynomials, rational equations, and what? And growth and decay equations. Okay, and basically this chapter is one of the longest chapters that you will ever see. Okay, it is so long. I know this. It's so long chapter. It's easy. Okay, it's all depends on the rules. So if you can't, like, if you see rules, you have just to memorize it. Jenna, your geometry is really weak. Okay, no problem, Jenna. Okay, so now this is what I say, okay? And the exponents, radicals. Now today we'll start with the rules of exponents. I will see if there is any time to start with the radicals. And then this chapter, it's gonna take like a week or more than a week, okay? So I will start with the first concept. The first concept, it's what we call an exponents. All right, what do you know about the exponents? Did you hear like about the concept of the exponents before? What does it mean, exponent? Anyone?
Isn't it the same as us?
Yeah, exactly. But I don't know. I asked, like, do I have a new student called, his name is Nabil? Is it the new student or same, my old student?
I changed from another phone.
You're who?
Sana.
Sana. Oh, hi, Sana.
Sorry.
Okay. Sana, you've been like absent for a lot, is it?
Yeah, sorry.
Okay.
I had some problems.
Is it okay? Is it okay to open your camera?
Yeah, sure.
Okay. All right. So we have right now a concept called an exponent. What is the exponent? The exponent basically it is this, which is when we have an a to the power of n, right? A to the power of n. This is what we call an exponent. All right. That's an exponent. So basically, what is the exponent? The exponent stands for, I have something called the base, and I have the n stands for what? Stands for the power. So I have a base and I have a power. This is what I say, this is what I call an exponent, all right? A base and a power. As an example, 3 to the power of 2, right? 3 to the power of 2. It's not 6. That's a mistake to say 6. It's not actually multiplying. You are multiplying the 3 with the 2. No. Basically, what are you doing? You're saying that 3 power 2, it means that you will repeat the 3 2 times. 3 multiplied by 3, and the answer is 9. And the answer is 9. So this is what we call an exponent. That's a base and that's a power. All right? A base and a power, that's what we call an exponent. As an example, let's say that I have a 10 to the power of 3. Who knows what is the answer? 10 power 3.
1000.
1000, exactly. Why it's a 1000? Because basically it's a 10 multiplied by 10 multiplied by 10. All right? So now this is the concept of having an exponent. We have formulas, we have rules to deal with the exponents. I will start with them, okay? I have rules to deal with exponents. Basically, I have 11 rules. I'm gonna see them one by one. So rule number 1, I'm going to show you an 11 rules to deal with what? To deal with the exponents. Rule number 1. All right, what is my first rule? My first rule is this. Once you have an a to the power of n, once you have an a to the power of n, what does it mean, a power n? Means that you're going to have a multiply a by itself. How many times? You keep repeating the multiply by a, by a, by a, until you get, as long as you get the n times. All right? Depends on n times. As an example, if you have a 5 power 3, what does it mean 5 power 3? It means that you multiply the 5 3 times. So you keep repeating the base as long as the power, okay? So 5 power 3, what does it mean? It means that you have to repeat, 5 3 times. You repeat 5 3 times, okay? So this is my first rule. That's the first rule. Second rule, rule number 2. Okay, so now we know that n, and here right now I'm talking about the n is a positive value, okay? N is a positive integer. Okay, what about if you have a power as a 0? Who knows what is the answer?
1.
1.
Exactly, it is 1. So any number to the power of 0, it's a 1, okay? A to the power of 0, it is a 1. That's something so important. Any number you have, for example, if you have a 300 to the power of 0, what is it?
1.
It's 1. 300 million to the power of 0, it's a 1. Even with negatives, -5 to the power of 0, what is the answer? 1, yeah? Even if you have a big number like -100 power 0, what is the answer?
1.
-1, because the negative is outside the brackets.
Thank you, Mr. Muhammad. Thank you, Mr. Muhammad. Exactly. Here, I have a trick. Okay? Here they have a trick. Look, now, this is so important note that if you have an exponent, you ask yourself this question. You ask yourself this question. What is the question you have to ask yourself? That this power is for which base? Look, now, for example, this power for which base is for A? This power for which base is for 300? This power is for which base? For the all of -5. But this power is for which base? Is for the 100 only, okay? I'm not taking the negative with me. So 100 power 0, what is the answer of 100 power 0? It's a 1. And what about the negative? I'm not going to touch it. I will keep the negative. Did you see? Did you see what just happened?
Yes.
So once you have a negative as a, or once you have a power, you have to ask yourself which base I'm going to use. All right? Any problem? So this is the second rule. Okay, how many rules I told you we have?
11.
11. So that's a rule number 2. All right, rule number 3. Rule number 3. Okay, rule number 3 is basically, once you have an A like a base, but the power is a negative number, like a negative n. The power is a negative number. Okay, if you have a power as a negative number, what you would do? It's basically, this is what you have to do. It's actually, when you have an A power -n, it's over what? Over 1. So you take the A and you make it denominator. You just move it to denominator. So this is what's going to happen. You say 1 over A to the power of +n. You see what just happened? This rule, you use it only if you have a negative power. Once you have a negative power, you just switch. You switch the term. If you have it at numerator, you change it to denominator. If you have it at denominator, you change it, you switch it to numerator. Okay?
Yes.
Right, guys. One more time. A power -n, A to the power of -n, if you have a negative. I'm going to show you an example. Let's say that I have a 3 power -2. Okay? What is the answer of 3 power -2? First of all, I have to deal with the negative. So I'm going to say it's going to be over 1. So I will just switch this one denominator. I will say 1 over 3 power 2. You see what just happened? And then I'm just going to do whatever I do. So I'm going to say 1 over 3 power 2, which is 3 multiplied by 3. And now the final answer is going to be 1 over 9. And that's our final answer. Okay?
Okay.
All right? Okay, nice. So that's a third rule. I'm going to show you another example about the third rule, and then I will move on. What if I have a 3 over 2 power negative 2? Okay, who knows what is the final answer?
12.
Okay, Muhammad, open your camera so I can't believe your answer. Is it okay to open the camera? Okay, the answer is 12. Look, why it's 12. Now, this number, I'm not going to touch it. 3 over. Right now, I have a negative as a power, as you can see. You see the negative as a power? I told you, once you have a negative as power, what you would do, if it was at numerator, you move it to denominator. If it's at denominator, what you would do, you move it to the numerator. So basically, once you have a 2 power negative 2, okay, so I'm gonna move the 2 power negative 2 to the numerator. Look what's gonna happen. It's gonna be 3. I'm not going to touch the 3, multiplied by 2 power positive 2. And now I'm just going to figure out what is the 2 power 2. 2 power 2 is gonna be 4. Now 3 times 4 is 12. So this is my final answer. Okay?
I thought we switched them both.
No, you don't flip the fraction. You don't do it like this, 2 power 2 over 3. No. You just you deal with the problem. And now which one is your problem? This is your problem only. You don't deal with the 3. 3 has no problem. I don't touch it. Okay?
So if I have a negative, I just move it upwards or downwards.
Exactly. Exactly. You don't touch anything else.
The numbers in the upper part, I don't do anything with them.
Yes.
Right?
Don't touch. Listen here. Don't touch anything else. You just use what? You just use your numbers. Okay. As an example, listen. You just use your problem. What is the problem that we have? I'll give it to another one. Let's say I have a 10, or wait, I have 10 power negative 2 over 5. Okay, what is the answer right now? Ask yourself, where is the problem? The problem that I have is the negative as a power here. You see, at numerator here, we have negative as a power. So what I'm gonna do, I'm gonna move this one. I'm not going to touch the 5, okay? So the 5, I'm not going to change its place. Why? Because I have no problem with it. You understand? I have no problem with the 5. So basically, this is what just happening. Sorry.
It becomes 10, 5 times
Yep.
10.
Exactly. So you just, this is your problem. So you move it denominator. So I'm going to say it's going to be multiplied by 10 to the power of 2. All right. So there is nothing left at numerator. Okay, you do it as a 1. If there is nothing left, you just do it as a 1. So now this is your final answer. 1 over 5 multiplied by 10 power 2. What is the 10 power 2? It's
100.
what? 20? It's 100. So now it equals 1 over 5 times 100. It's a 500. And that's my answer. 1 over 500. It's easy, is it?
If it's in the upper part, I move it down and put 1 instead. And if it's in the
There is nothing left. But if there is a number left, like if this is a 2 here, let's say that there is a 2 here. So you don't do the 1 because there is a number. So you use the 2. You understand? 2 over 5, exactly. And then here it's going to be 2 over 500. And you can even simplify it to say 1 over what? 150.
But if it's in the lower part, I just move it upwards and cancel it.
Actually, you know, if it's in a like denominator here, when you move it, it's okay to say also that there is a negative, there is a 1 here, but there is no need to do the over 1. Like the answer is 12 or 12 over 1 because it's actually the same. So that's why I didn't say there is a 1. But here I have to.
Yes, okay.
Okay?
Yes.
So that's rule number 3. That's rule number 3. Rule number 4. Rule number 4. Okay, rule number 4 is this. Once you have a fraction and the power is negative. Look, this is so important, so important. Now the power is for whole of the fraction. It's not only for the numerator. It's not like this. This is different than this. Okay, listen carefully. A power negative n over b. This one and this one, they are so different. Here the negative n, it's only for a, but here the negative n is for the whole fraction. Now my rule is if you have a fraction to the whole power, okay? If you have a fraction to the whole power. So what do? You know what do you do? Right now, Mr. Yahya, it's if you have a fraction and all of it to the power, this when you just flip your fraction and you make the power positive. Again, when I can use it only once your power for the whole fraction, okay? If your power for a whole fraction, this is when you use it. You have to be careful. Okay, guys?
Okay.
Okay? As an example, I'm gonna show you an example. Let's say right now I have a 5 over 2 to the power of -3. Okay, what can I do right now? I can do this, which is now ask yourself, is the power -3 for whole of a fraction?
Yes.
Yes. So the power -3 for numerator and denominator. What can I do? I just do this. It's going to be 2 over 5 and the whole to the power of +3. You see what I did? I moved 2 up, I moved 5 down, and then I flipped. I changed the sign. And now, what do I do next? 2 over 5 power 3. This is what you do. It means that the 2 over 5, I have to repeat it how many times? 3 times. So 2 over 5, 2 over 5, and 2 over 5. So my final answer was going to be 2 multiplied by 2 multiplied by 2. It is going to be 8. 5 multiplied by 5 multiplied by 5. It is going to be 125. So that's my final answer. This is what I get.
Can I distribute the
You can. One of the formulas. Yes. Next. But that's easier.
what I mean?
Yeah, that's the distribute the power for 5 and for 2.
Yes.
And for calculate each. Yeah, the same.
Okay.
Okay. Sana, what's going on with you, Sana? The internet?
Yes.
All right. Okay, rule number 5 right now. Rule number 5. All right, rule number 5 is so important also, which is once you have, guys, just let me do this. Once you have an a to the power of n, and you are multiplying by a to the power of m. Now, look what I do have. I have an exponent multiplied by another exponent. I have an exponent multiplied by another exponent. An exponent multiplied by another exponent. What is the answer? The answer. Exactly. You do just the same base. This is so important. I can see that the first exponent has the base is what? Here the base is a. And here, what is the base again? The base is also a. Now I can say that these two, they have the same. They have the same base. Yes. So these two has the same base. Once you have the same base, but the powers are different, what you can do this, which is you can say that it's going to be n plus m. I can say, I just add the powers. Why I can add the powers? Because basically, once I have the same base, also it's like it has to be the same base. If it's not the same base, it means that I have a mistake. Okay? if I have a same base, I can add the powers. My voice lagging. Guys, is my voice lagging?
No, not
Hello?
really. Just a little, yeah.
Little?
I said just a little.
I don't know. I guess that there's lots of problems in here. Just let me close all the applications. Can you hear my voice?
Yes.
I'm trying to close all the other applications. I hope that this is gonna work. Bluetooth is always working. What else? This is nothing. This is the stem downloading. Close. Exit. I don't know when it started to download this PUBG. This is for my pen. This is for Zoom. This is for screen, the security. Okay. Now I hope that this is working right now. Okay, so once I have a same base, what I said that if you have a same base, what you do, you add the powers. Same base, add the powers. Okay, that's rule number 5. I'm gonna give it to you an example about rule number 5. Let's say that I have a 3 power 2 multiplied by 3 power 10. What is the answer of it?
3 to the power 12.
3 to the power of 12. 3 to the power of 12. Who's answering, Noya?
Yeah.
Okay, it's been 20 minutes here, Noya. Okay, 3 power 12. Now, do you understand why it's 3 power 12?
Because we add the bases.
Because we added the bases, exactly. We added the
And
bases.
exponents, exponents, not the
Powers, the
bases.
powers, yes. Right now she's trying to say that because the bases are the same, 3 and 3, both of them are the same, and the sign in between them is multiplication, so I can add the powers. That's rule number 5. What about rule number 6? Okay, rule number 6, it's somehow exact same as rule number 5, but instead of multiplication, I will deal with division. As an example, or the formula is, once you have an a power n divided by a power m, okay? And again, you have to be careful about the base. Right now, what is my base? The base is a, the base is a, and this one here has the base is also a. So what you would do as a rule, the formula it's saying to you this, a, oh, wait a minute, before talking about the formula, you might see this as this, a power n over a power m. Okay, you might see it like this shape, or you might see it like this. Okay, both of them are the same concept, which is, what is the formula right now? Right now is this, a, you subtract the numerator power from the denominator power. So n minus m. Again, this is so important. The numerator power minus the denominator power, okay? Numerator power minus denominator power. As an example, if you have a 3 power 10 divided by 3 power 2, what is your answer is going to be? I will tell you this. Check, please. Do you have a base here same as the base there? I do, which is a 3. So because they have the same bases, what I'm doing the power 10 minus the power 2. So now I'm saying 10 minus 2, what is it? It's going to be 3 power 8. 3 power 8. So that's rule number 6. This is rule number 6. Okay. All right, guys. You said
Yes.
yes, Jana. Okay. So now an example, and let's see who gonna give it to me correct answer. If I have a 2 power 3 over 2 power negative 2, what is the answer?
2 to the power 5.
MashaAllah, Osama. I didn't even finish the question. 2 power 5, exactly. So the answer right now it's 2 power 5. Why 2 power 5? Why power 5?
Because 3 minus the negative 2 is plus.
I told you exactly. I told you the formula is like this. Do you have the same bases? Yes, I do. So I have the same base as 2. So I'm going to say that numerator power minus the denominator power. So the denominator power is already negative, and I'm subtracting from a negative. So the negative and negative, it is going to be positive. So I will say 2, 3 plus 2, which is going to be 2 power 5. And that's the final answer. Okay? Now we finish from rule number 6.
Can I
Rule
ask
number
something?
Yes.
Aren't we supposed to flip like to the numerator?
You can do this, but listen, what was it? It was 2 power 3 over 2 power negative 2.
Yes.
Tasneem, tell me which one is your problem? Where is my problem?
The negative?
This one, the problem, yes?
Yes.
Is this one is a problem?
No.
Don't touch it. If it's not a problem, don't touch it. Keep it as 2 power 3, okay? So I told you this rule. Yes, I told you that if you have a negative, you move it up and you make it positive. Yes or not?
Yes.
So am I going to touch the 2 power 3? No, I'm not
No.
going to touch it. I will keep it. And now when you move it, it's basically there is a multiplication. So you multiply. And now you move it up and you make it positive. Yes? It's going to be 2
Yes.
power positive 2. And now use the rule number 5 because you have the same bases and you have different powers. What do? You add the powers. So you do the same base and you add the powers, which is exact same answer.
Mm.
So you can use this, you can use that. All of them are gonna give it to you exact same answer. Exact same answer, okay?
Okay. Yeah, thank you.
Muhammad, Mr. Muhammad, don't close your camera. And Usama, you have a nice ceiling. And now you have a nice nose. You have 2 phones, yes, Muhammad? One's for to see and one's for camera, is it? No, not Muhammad, sorry, Usama. I'm talking about Muhammad, sorry.
I
Usama.
have a PC, mister, but it doesn't have a camera.
Okay, and you are using the phone for camera, yes?
Yes, and microphone.
Okay, put your phone like next to the PC and you'll be good. Okay, this is the first time I see your face, by the way, and I always recognize you from your glasses. But it's like this now. Can you? Yes. Yes, that's nice. Thank you, sir. And Sana, why are you closing camera, Sana? Now, Jana, she's in Syria, okay. She can't open the camera. But Sana, why you close the camera? Rule number 7 or 8. What we did?
7.
7. Okay. So rule number 7. What is rule number 7? It's basically now in rule number 5 and 6. Look, in rule number 5 and 6, we have what we said. We have a same base. Yes, I have a base is the same. But right now in rule number 7, the bases are not the same. If you have a different bases, look, for example, if you have an a power n multiplied by b, you see, it's different bases, but with the same power. So now I can say that the power is n, the power is n. So now I can say here, I don't have a same base, I have a same power. What I do, this is what I do. I do basically, I open a huge bracket and I multiply the bases, just multiply the bases without the power, and your answer, you do it with the power. This rule is so important. This is so important rule. Why it's so important? It's basically, this is why. I use it a lot. I use this rule a lot, but I don't use it from left to right. I use it from right to left, okay? What do I mean by this? I mean by this, sometimes you will see this, I have a 5xy power 3 as an example. And I'm looking to simplify this expression or whatever. I don't know what is the question is gonna be, but this is somehow. So you take this 3, you distribute the power, same as I'm doing here. Right now I have an n, so I can distribute the power n for A and for B. If you have like C multiplied by C, so you distribute it for C. If you have multiplied by D, E, I don't care. As long as inside the bracket, it is only multiplication, all right? So now what I can do, I can say that 3 distributed for 5, for X, for Y. So the answer is gonna be 5 power 3 multiplied by X power 3 multiplied by Y power 3. If you have more multiplication, if you have a Z inside, so you also distribute the power 3 for Z. Okay? Again, you can do it, you can keep doing it as long as it's a multiplication inside the bracket. It's a multiplication here. There is no addition or subtraction. Okay? For example, now X plus Y plus Z to the power of 5. What is the answer of this one? Do you know what is the answer of this one? Can I distribute?
No, you have to add first, right? Get the sum.
No.
I cannot, guys, this is one of the huge mistakes that a student will do, okay? And you're going to do this mistake, by the way. You know how you do this mistakes? I would remind you, inshallah, I will remind you, well, you will do this mistake. When you will do this mistake, you will do it here. When you will see that X plus 2 power 2, all right? What you will say, I'm gonna tell you what you will say, what you will go to do. You're going to do this. You take the power 2 for X, you say X squared plus 4. You distribute like this. Is it? You're going to do this, that's a mistake. This is wrong. I just told you, you cannot distribute power for first and second if there is a multiplication. Naya, tell me what you're doing. What do you say?
A squared plus 2ab plus
Yes.
b squared.
Exactly, thank you. This is a formula, okay? That's a formula. I'm not talking about the formulas right now. I'm talking about the mistakes that you would do. You cannot distribute the power if there is an addition. And you will do this mistake, okay? I'm gonna remind you. Please don't do it. Please try to be careful, okay? It's a mistake to do this. That's the formula, exactly, Ajana. It is, if you have, for example, a plus b squared, it's an a squared plus 2ab plus b squared. I know you know it right now, but inside the exam, I don't know what's happening to you, so you will be stressed out, and most of the students doing this mistake, okay? Don't do this mistake. Again, you cannot, my idea was you cannot distribute the power if there is an addition or subtraction, okay? Can I subtract if there is a multiplication? Yes. Can I dispute, sorry, if there is a multiplication? Yes. Can I distribute if there is a division? The answer is also yes. That's rule number 8. Rule number 8, it's if you have an A over B and all of that power of n, Tasneem, you ask for this. So now this is power of n. You can take the power for numerator and the power for denominator. There is no problem with this. Okay? So I can distribute with division and multiplication. No problem at all. But you cannot distribute if there is multiplication, addition, or subtraction. Okay, I have a question. It's not a SAT question. It's just general math question, okay? Who knows how you do A plus, for example, let's say 2B power 4? Who knows what's
Pascal triangle and the binomial expansion.
Yes. Pascal triangle, binomial expansion. Do you know, Muhammad, how you do it? Tell me Pascal triangles. Tell me the first 5 rows of Pascal.
1 1 1 up, then 2 1, then 1 2 1, 1 3 3 1, 1 4 6 4 1, 1 10.
1
1 5 10 10 5 1.
Yes. Anyone knows what we're talking about? Do you see this before?
No.
No? Muhammad, when did you took this?
Grade 9.
Grade 9. Which school? Turkish school?
No, in Saudi.
Ah, in Saudi Arabia. Okay. Type. This is what we call the Pascal triangle, and Osama is writing. Okay, you are using convention. Osama, do you know what is this C stands for?
Combinations.
Combination.
Combination. Do you know that there is a combination in your calculator?
Yeah, Mr. We studied it.
Yeah, we use the combination in the, like 4C4, for example. Okay, nice. Thank you, Osama. All right, so no need for this. In SIT, we don't have this at all, okay, anymore. So but only we have the formulas. So let's go back to our lesson. Rule number 8, it's if you have a division and there is a power n, what I can do, I can distribute the power for numerator and for denominator.
Mr.
Yeah.
If I have like A times B, in between brackets, A times B times C plus D.
You can't.
I can't.
No,
As soon as I say a plus, I can't.
you can't. So if, for example, you say this, you mean that you take the power for A and B and C and you skip D. No, that's a mistake. You
No,
can't.
yes, I'm just asking.
You can't. And once you see plus or minus, you can't. Jana, I get the C from a calculator here. You press shift, and here in my calculator, I'm gonna press on the division. C, a shift and division, okay?
What is the C for?
And what
Something
if
called combination, okay? That's a probability.
I have A times B divided by C?
Okay, here you can, no problem. A
All of them?
times B divided by C like this and power n.
Yes.
All right, no, here it's okay. Why? Because I don't have a multiplication, I don't have an addition, I don't have subtraction. So what I can say right now, I can distribute the power for A, for B, and for C. A power n, B power n, C power n. Here it's okay.
Okay.
All right, guys. So for now, until now, we have how many rules we did? We did 8 rules. All right, rule number 9. All right, for rule number 9, this is what I'm doing. If you have an exponent, all right, if you have an exponent and all of that, it's raised to the power. So I have an exponent with a power. I guess you see this before. What do?
We multiply the n
You
times
multiply
the
the
n.
power. Exactly. So you do the same base and you just multiply the power with the power. But there is one small condition here, right? One small rule. What is the rule that you have right now? It's actually you have to have the power, the second power, the m, has to be for all of the exponents. What do I mean by this? Like the power m has to be inside the bracket right now, like this. It has to. Okay, I'll give it an example. What is the answer of 3 power 2? All of that to the power of 3.
3 power
3 to
6.
the power 6.
3 to the power of 6, exactly. 3 to the power of 6. All right, why I do this? Because the power 3 is for which base is for the whole of this base. So now I can do the formula. Now look for the example that most of the students doing the mistake with it. What I have the answer 2 power 3 power 2. What is the answer?
2 power 9.
Exactly, Mr. Muhammad. Now I'm gonna say it's gonna be 2 power 9. It is not. If you say 2 power 6, same as this, I will tell you that's a mistake. Why? Why this is a mistake? Because actually the power 2 is there is no bracket. Okay, there is no bracket right now. So the power 2 is for which base? The power 2 is for this base, for 3. So I'm gonna find the answer of 3 power 2 first. 3 power 2 first. What is the answer of it? It is a 9. You understand? Then the base 2, I'm gonna keep the base 2. If there is a power, it's actually so different. 2 power 3, power 2, that's how you say yes. Now I can say 2 to the power of 6, and now it's correct. But here it's incorrect. Why? Because of the brackets. That's rule number 9. Rule number 10. Rule number 10. All right, what is the rule number 10? I'm going to show you rule number 10. It's if you have, what just happened? Spotify. What is this Spotify? Who opened Spotify? La ilaha illallah. What is this application? Spotify. La ilaha illallah. Who opened the Spotify? La- Anyone open the Spotify? Do you see me opening Spotify? Do I have even Spotify in my laptop? Okay, nice. Alhamdulillah. Okay, so now rule number 10. Rule number 10. What is the rule number 10? Is this. If you have a base, if there is a base, and right now the power is fraction. This is so important. Okay, so by the way, this is what we call the relationship between exponents and radicals. Okay, the relationship between exponents and radicals. All right, so a to the power of n, a to the power of n over m, a to the power of n over m. What you would do, how you change power into radical. So you just do a radical, which is a root, if you know it. It's a root. What is your base? What is the base right now? Here I have a base a. I'm gonna keep the base a here. All right. What is the power? The power is gonna be the numerator, and the denominator is gonna be something called index for the root, for the radical. Index. Sometimes I don't know if you know, if you heard about the index concept before. The index is basically square root, cube root, the fourth root. Do you hear about the index? This is what we called as a name. We called it as an index. Okay, the index of the root. So this is how you change from a fraction power into radical. Same thing. If you have like a radical, you change it as a power. No problem. It is exact same thing. Exact same rule. Let me show you an example. If you have a 3, what? Tell me.
Radical is the jadr.
Yes.
Okay.
بس الجذر وليس الجذر التربيعي. الجذر in general. Okay. So 3 power 2 over 5. How can I change it into radical? I change it. I will do radical. Okay.
Join index.
Exactly. Which one is the base? The base is a 3. Which one is the power? That will be a power for the radical, and that's going to be the index for the radical. So it's going to be 3 power 2, and the index is a 5. So how I would do it, I would say that's 3 power 2, it's a 9, and it's going to be the 5th root of a 9. Okay? Yes, inner, outer. Yeah, I like to say, call them power and index, easier. Inner over outer. Okay, Jana, no problem. Okay. All right. I have one more question. There is one more rule, by the way, but there is a question I have to ask, which is if you have a like root of x, how you change it to power? Who knows?
X to the power 1.
X over 1 over
Or
2.
half.
Yep. Here, guys, here, once you see a square root of x, there is a hidden invisible numbers. I don't know if you know, guys, if there is no power, let me just zoom in somehow. Here, guys, if you see this square root of x, okay, here the power, do you see the power? There is a number. There is a hidden number that we don't write. Usually we don't write. Why? Because it's actually, because we use it a lot. We use numbers a lot, like 3, 5, 10. Because we use them a lot, so there is no need to write every time power 1, power 1, power 1. So they said, if your power is 1, so there is no need to write the power. Okay? So if there is any number, any term, anything, okay, any variable without a power, what does it mean? It means that there is a power, which is there is a 1, but we don't write it. We don't write the 1. Am I clear? That's first. Second of all, if there is no index here, do you see that there is an index, any index in here, any number?
No.
No. If there is no index, it means that there is an index and it's a 2. Why we don't write this 2? Again, because we use a square root a lot. This is what we call the square root. And now using my rule, I'm going to say the same base, and I will divide, same as Jenna said, the inner divided by the outer, like the inside divided by the outside. And the inside is 1, and the outside is what? Is 2. So this is how we change from a square root into power. But again, I told that usually I don't have a power 1 and I don't have a square root of like the index 2. I just do this, I have this, and I just change it to what? To power half. Using same concept, if you have like cube root of x, what I do cube root of x, what is it?
X to the
X
power
and
of
1 over 3.
1 over 3, exactly. Why 1? Because there is no power here. So you just divide the inside divided by outside. So these are the 10 rules. I guess I have here a space. I'm going to show you rule number 11 in here. Okay, the last rule that we have right now is rule number 11. Rule number 11, what is it? I'm going to show you. Guys, just stay with me for a minute. Rule number 1 until 10, all the rules from 1 to 10 are you're going to use it to simplify. Listen carefully. I will give it to you a question and I'm going to tell you simplify. Okay, but the only one that we have a rule number 11, I'm going to give it to you to solve. Okay, like in rule number 11, the only one with concept of solving with the equation. So now I have an equation rule number 11. They said in the equation number 11, if I have an a power n equals to the a power n, listen, a power n equals to the a power m, it means this. If the bases are the same, listen, if the bases here, base is a and the base is a, if the bases are the same, it has to be the powers the same. Do you understand? The powers have to be the same. This is so important rule, guys. A left-hand side and the right-hand side, if you have here and there, both of them with the same base, what does it mean? It means that the power here and the power there have to be exact same, which I will say the power n right now equals the power of m. This is so important, so important. I will give it to a quick example about question number 11, and then we will open our notebook and then we will solve some questions. Quick example, I'm gonna say 2 to the power of x, if it's equals to 8, all right? I will start with the easy one, all right? What I'm gonna say, how I'm gonna solve it. I know you will say that x equals 3 directly, but why? I will use this. Now, I don't know if you know this, but the 8, I can replace, instead of 8, I can say that it's gonna be 2 multiplied by 2 multiplied by 2. Yes or not?
Yes.
So the 8 basically it's 2 power 4, 2 power 3, sorry. So I'm going to delete the 8 and I will replace instead of 8 by 2 power 3. Now I'm going to use rule number 11. What is rule number 11? It says if you have at the left hand side and at the right hand side, if you have the same bases at the left and at the right, you have the same bases. What does it mean? It means that the powers have to be exact the same. So x have to be equals to 3. And this is it. Okay? We finish about the exponents. There is just some things that I guess you knew. So I don't know if you know that the 4 is equals to square. I guess you know it. The 8 is equal to 2 cubed. The 16 is equal to 2 power 4. The 32 equals to 2 power 5. 64 is equals to what? 2 power 6. And that's it. That's enough. I don't know. 128 you want? Yeah, 128, 2 power 7. Also that you have to know that 9 is going to be 3 squared. 27, it's 3 cubed. 81, it's 3 power 4. I guess that's enough with 3's. 25, it's equals to what? To 5 squared. 125, it's equals to 5 cubed. 625, it's equals to 5 power 4. I guess that's enough. What do you think? Yeah. Here, this list, it's what we call the golden list. Guys, listen carefully for this note. Whenever you have an exponent question, it's obviously that if you like, you will see, you figure it out like this is an exponent question. If you have an exponent question and you have any of these numbers, don't keep them as big as they have. Don't keep the 8 as 8. No, change the 8 as 2 cubed. Why you will change it? Because it's going to be much easier to deal with. Again, listen again, what I'm saying. If you have an exponent question, and by the way, most of the exponent questions is going to be with no calculator. You cannot use a calculator. That's why you have to be good with the skills. You have to use your hands to solve the questions. So if you have an exponent question and you have one of these big numbers, so don't keep these numbers as they are. Don't keep the 125 as 125 because you would never find the answer as 125. It's going to be so complicated. What you would do then, you just change the 125 into what? Into power, into radical, or into exponent, which is 5 power 3. And then you deal with it as one of the rules that you know. Okay? Okay. Should we have a break or let's solve some questions? Did you even get tired? I guess you just started.
Can I take a break?
Let's vote. Let's vote. أنا ديمقراط. Radwa, break, yes or not? Don't tell me as you wish. I don't wish. You are muted, ya Radwa. You're muted. Still muted. But Naya, yes or not? Break or not?
Yeah.
Yeah, for. Yes for break or yes or no for no break?
Yes, for break.
Yes for break. Okay. So we have one vote for Osama. Obviously, Osama from now he took a break.
Then break.
Break.
It's
So
2 hours. So like each hour we should have a break.
no one needs needs informations. Yahya, break or listen?
Listen.
What? Listen, Allahu Akbar. Tasneem.
I said break.
So we have 3 breaks. Muhammad,
No break.
4 break. Okay, then break. Because you the majority.
No break.
No break. 3-2. Okay, 3 breaks, 2 no break. Jannah.
Can we solve a couple of questions first?
Okay, 3-3. Nice. Sana.
Where's your break?
Break. Sana break or no break? ما بسمع. I can't hear.
Break.
Break 4-3. Osama, he's now you're the vote in your hands, Radwa.
Listen.
Listen, 4-4. Allah. But then 4-4. Flip a coin. If it's head, break. If it's head, it's tails. So no break. Okay, some questions. we have a break, okay? Just some questions so you not forget the rules. As you can see that this chapter is like, I already uploaded everything to your platform. Let's start to solve questions, okay, for this. All right, so question number 1. He's asking for what is the value of this. Now, what I need you to solve a question and text me on WhatsApp. I need to see how you're solving the question, okay? I don't care about the question itself. I care about how you solve a question. All right, guys?
No calculator.
No, all the questions with no calculator. So right now, you have my WhatsApp number. So please solve it on a paper, take a picture and send it to me.
There's a rectangular box. Oh no, it's there. Okay. Now you don't. Oh, okay.
Now,
Yeah, it's clear. It's clear.
nice, Ridwan, perfect. This is your number, Jana, yes? Jana?
Yes.
Jana, you have a problem. Check again at the beginning, okay? At the beginning. Check that. Did you took the question correctly or not? You have a mistake here, Jana. Nice, Muhammad. Correct. Perfect. Tasneem, why you have a denominator 3/7?
I changed it to so I could simplify
Okay, but why 7?
because 81 doesn't 81 equal 3 power 4 and then 3 power 4 times I mean power 3.
4 power 3 power. What you do, you multiply the powers.
Oh, it's supposed to be 12. 12. Okay. Thank you.
And this is Naya's, yes? And Naya, you can't do this. Don't change at all, ever, never change the 3 power or any power into numbers as normal numbers, okay? Listen, do it again, but don't do the 3 power 5 as the answer. I don't care about the answer. I told you, keep it as exponents and use the golden list, yes. But use the exponent. Don't change the exponent into numbers at all, okay? Try again and text me. Yeah, that's correct, but it's like you can do it faster. There is a different way. That's correct, but it's so long. I don't know. Do you use a calculator?
No.
There is a faster way.
Can
Now
you say
correct it.
3 to the power 8 over 3 to the power 4, then take the 3 power 4 or to the up and
Say again, Naya.
can we say like 3 to the power 5 multiplied by 3 over power 3, so I can say 5 plus 3 equals to 8?
Write it down. I don't understand. Write it down on the notebook. Show me. I don't understand. Okay, let me solve it. Anyone still didn't text me? Sana, where is your answer, Sana? Sana? Sana, where is your answer? Jana, your mistake is by this. Jana, your mistake is you took 27 only. You didn't take the power. That's your mistake, yeah, Jana. Someone said Mr. Who said Mr.?
No, I was saying I sent you my answer. Is it correct now?
Yes, I told you it's correct now.
Okay, thank you.
Okay, let me solve it. Everyone, stay with me for a minute. If you didn't know how you solve it, this is how you solve it. Guys, I see that 3 power 5 multiplied by 27. I told you that the number 27, I don't like to see 27. I don't like to see numbers as big as they have. No, I will change them. How I'm going to change them? I'm going to change them using this list. I told you that I have a golden list. You see it? So by the way, he will never give it to you numbers that you can't use. Like you can't use from a golden list. He will never give it to you 50 or 75. No, he will give it to you numbers that you can use. You can use from a golden list. So that's a 27 power 3 over 81 power what? Power 3. Again, what I'm doing, I'm going to delete the 27. I'm not going to keep the 27 as 27. I will change it. I know, and you know that the 27 is what? Is a 3 cubed, yes or not? So I deleted the 27 here, and I'm gonna do it as a 3 cubed. And I know, and you know that the 81 is what? Is a 3 power 4. So I'm deleting the 81 right now, and I'm doing it as a 3 power 4. Okay? And now I'm gonna use one of the 11 rules that we have, all right? One of them says that if you have a power and a power, okay, and especially there is a bracket, what does it mean? It means that you multiply the power, so 3 power 5 multiplied by 3 power what? 3 times 3, 9, over 3 power 4 times 3, it's a 12. Do you mind? This is using rule number 9, I guess. Rule number 9. And now I have a denominator. You see the denominator? I have a multiplication. I have a same base. So what I would do if I have a same base and multiplication, I'm going to add the powers. So let's try to add a 5 and a 9. Do you understand? All of them, I'm depending on rules. I'm just moving using rules. Then 5 plus 9, it's a 14. So 3 power 14 divided by 3 power 12. And now, do I have a rule? Yes, I do. If you have a division and you have a same base and different powers, what I told you, to subtract the numerator from denominator. So I'm just going to say 3 power 2. And the final answer, 3 power 2, what is it?
9.
And that's how you do it. All right, Naya?
Yeah, that's what I meant when I told you like the 3/5 multiplied by 3/9. Can I add them?
Yes, this is a rule. You can do it. Okay, no problem. Okay, let's have a quick quick break. Now it's 6:50 till 5:50. What is it? 6:50? Oh, 6:50. Let's have it to 7, and then we have a last half an hour. Okay, guys.
Mr. Can
Don't
I
be
ask
late.
quickly?
Yes, Tasneem.
No, in the end of the class, I have there's a question I didn't understand while I was solving. Can I ask you in the end of the class?
You can now take a screenshot so I can prepare it for you. Okay, and send it to me.
Okay, thank you.
See. Okay, guys, I'm back. Okay, try to solve question 5. Yeah, come on, Rahia, Radwa, Tasneem, Naya, Jana, Sana, are you here?
Yes.
Guys, are with me? Anyone with me?
Yes. Yes.
Open your cameras. Okay, open your cameras. I feel myself like I'm by myself. يلا سنة جنى يحيى. I need you to show me your answers. Show me how you're doing. Like, just texting right now. Muhammad Jadwa, show me why, please. Okay, nice, Jadwa. Okay, let me solve the question. I know I get bored. Okay, stay with me, everyone. Stay with me. Now he's saying to you that I have this expression, and he give it to you also another information, which is r plus s equals 6. What is the value of t in the equation above? All right, he give it to you this information, and he's asking for a value of t in the equation above. You can hear my voice, is it?
Yes.
Okay, so now what I'm doing, what I will try to do, I'll try to do this. I'll take the left-hand side, which is x power 5r over x power 3r minus 2s, okay? I'm gonna apply a formula. I said to you this, if you have a base at numerator and the base at denominator, if I have a same base here and there, if I have a same base here and there, I'm gonna do the same base and I'm gonna subtract the numerator from denominator. And now because the denominator has two terms, I'm gonna open a bracket and I'm gonna say it's gonna be 3r minus 2s. Okay, so x, now 5r minus, I'm gonna distribute the negative inside, 5r minus 3r plus 2s. But it's gonna be plus. Why? Because I'm distributing. And all of that is equals to what? To the x power t. All right, 5r minus 3r, 5r minus 3r is gonna be 2r. So right now I have an x power 2r plus 2s, it's equals to the x power t. And if you remember the last rule, rule number 11, I told you, if you have a left-hand side and the right-hand side, the bases are the same, it means that the powers are have to be the same. So I'm gonna say that 2r plus 2s have to be equals to the t. I have this information. And I already have, what do I have? I have this, which is I have an r plus s. I have a normal r plus normal s
Multiply
equals
by
to
2.
6. Thank you so much. I'm going to multiply by 2 all equation. So 6 times 2, the t have to be equals to 12. T has to be 12. Okay, do I have another way to do the question?
I can try the numbers.
Like what?
Like I exchanged t for 6 or 12 or 1830. What I mean, no.
The t?
Yeah, they asked for the value of t, right? No.
Yeah. Okay. So what do you mean? You use these?
Yeah,
Okay. How you use them?
I replace t for the numbers in the choices. No.
Like if you took, for example, you took t as 6. Okay. What is next?
I use the same class. Never mind. I don't know.
Of anyone else?
Find values for r and s.
Yes.
Work with the same equation, r plus s equals 6, to work as her solution. That's new solution.
Just give me a minute, sorry. Yeah. So now, as you said, Radwan, you said that we substitute instead of r and instead of x, s. Yeah. So listen, this way I liked. Okay, I liked this way so much, which is right now I have an r plus s. It is equals to 6. Okay, r plus x equals to 6. Now look what I have. If I substitute instead of r and instead of s by a value, and any value I need, it's gonna be okay. Any value, it is gonna be okay. Okay. So r plus s equals 6. I'm gonna go with r as a 6 and s as what? 0. Yes. So I will go with r as 6 and s as 0. Or wait a minute, I will do it like much better. I'm gonna do r as a 0 and s as a 6. You can go any value you want. Okay, I can go r as a 3, s as a 3. I can go r as a 5, s as, but actually I like to have one of the values 0 because it's gonna be much easier. Look what is gonna happen. Look what's gonna happen. X to the power of 5 times r. What we said r is
0.
5 times 0.
0.
5 times 0 is 0. Over x. Listen, 3 times r, which is 3 times 0, it is a 0. Minus 2 times s, s is 6.
12.
So 2 times exactly is going to be 12. So now, x power 0, it is a 1
1.
over x power what?
Negative 12.
Negative 12. And now because I have a negative 12, I'm going to move it
Flip.
up. So it's flipped. It's going to be positive 12. And that's the answer.
Any number I choose, as long
Same
as
answer. Yes.
okay.
Any number you choose. Any number. Okay? Okay, yeah, more. Let's do more. Okay, power 9. When simplified, what is the number? When simplified, what is the number? Don't forget, who remind me with the rule of if I have a fraction as an exponent, a power n over n. What is it?
Power over index.
What?
Power over index.
Power over index. So I'm gonna say it's gonna be it's radical a power n and the index as an m. Have fun. Muhammad, this is for the question 9.
No, this, yes, for question 9.
You cannot use a calculator, huh? You can't use
No.
a calculator. Okay, what is the answer here? I need an answer. I need a number. Okay, Radwa. Yalla Sana. I'm waiting your answer. Jana, Naya. Show me your answers. Sana, are you even with me? Sana? Sana, did you came back?
Are we supposed to solve this question without calculator?
Without, do you solve with the calculator, Radwa?
No, at the end of the question, I swear. Just to
Show
make
me
sure.
then. Take a picture for your answer. Let me
Okay.
see. Okay, Jana. Sana, Naya.
How are we after we get the number, like under
But
the,
it's a really big number. Like when I did it, it's like 4,000 something.
And after that, you have to find the cube root of it.
how do we
Yes.
find the cube root of the
Try to
number?
think then, okay, Tasneem, try to think about the number. You multiply 3 times by each other to get this big number. Nice. Radwa, you use a calculator. Don't use a calculator. I don't need a calculator.
Yeah, I texted you that I was just asking about the cubic number 40,096.
Your method is incorrect.
Can you solve it, please?
Okay, listen. Do you remember what I told you? Actually, I give it to you as this as a start. I wanted to trick you. And alhamdulillah, everyone tricked. Guys, do you remember what I told you about the golden list? I told you if you see an 8, don't leave it as 8.
Power 3.
I said this, yeah? So 8, I'm not going to keep it as an 8. I'm gonna say that the 8 same as 8 2 power 3, yes or not?
Yes.
Okay, so 2 power 3, I'm gonna say it's 8 power 4 over 3. And instead of 8, I'm gonna do it's a 2 power 3. Now I'm gonna apply a rule. What is the rule? It's when I have a power of a power, you multiply the powers. So basically you say 2, 3 multiplied by 4 over 3. And I don't know if you know it, but 3 multiplied by 4 over 3, you cancel the 3 with the 3, and then you get 2 power 4. All right, 2 power 4, what is it? It's easy, 2 by 2 by 2 by 2, ya Radwa, which is 2 times 2 is a 4, 2 times 2 is a 4, 4 times 4 is 16. I didn't use a calculator, ya Radwa. Okay, don't use that rule. I told you, I asked for that rule because I want to trick you, but use this.
You're tricked.
You're tricked. I know. Don't be, please. Okay, I know that. Listen, even listen. You using your logic. Just use your logic. when you have an 8 to the power of 4 and the cube root of that, there is no way that SAT people will ask you to find 8 by 8 by 8 by 8. No, don't do it. I prefer not to do the question. I will leave the question than solving this. Don't do it. It means that you have like you're in the wrong way. Okay? You will never face this type of questions or this type of problems. No, it's always there is a different way to do it. Always, okay? Okay, يا جماعة. طيب.
Okay.
So always not follow my instructions. This is a question with a 3 seconds. Okay, you can solve it in 3 seconds. So have fun. Question 8. It's so easy. I'm not going to solve it. You can challenge me with me. There is no even. Correct, Radwa Muhammad. That's nice. Come on, boys. Come on. No, yeah, perfect. Yes. Sana, that's correct. Yalla Yahya, I want you to answer Yahya. And Jenna. Tasneem, did you send me the answer? Okay, Jenna, correct. Yahya, Tasneem.
Yes, just one second.
Correct, Tasneem. Yahya. All right, nice. All of you get the answer C, correct. But try to be faster next time.
The negative here, is it for the whole radical or -4 only?
No, the negative is just negative. Don't touch it. Negative, just negative. You understand? Like try to make sure yourself that you don't see the negative. Deal with the power, the fraction power, which is 1/4. 1/4 it means that the power 1 and the index is 4. Inside 1, outside 4. You understand?
Yeah. Okay.
This is it. This is it. Yeah, it's actually C, obviously. Okay, more questions about the exponents. This chapter, okay, it has a lot of ideas, still. I don't know, we need a week or a week and a half. Okay, now you have a calculator. You can use a calculator to have this, solve this. Have fun.
Because it's a long equation, my calculator is stuck. Like I put everything, I put shift solve, it's not giving me the answer.
Yeah, your calculator is gray or black
Black.
and stuck.
Yeah.
Alhamdulillah. Okay, then don't use shift solve. Try to take all the exponents.
I can use a calculator.
Yeah, I said yes. You can. Do you see the calculator sign?
Oh, okay.
Nice. That was perfect. And Muhammad is perfect. Okay, let me solve it for you.
Just 1 second.
1 second. 1 second.
I sent you on the chat. Is it right?
You tell me. Do you see your answer in the option?
Oh, I didn't. Oops, sorry.
Yeah, no, incorrect.
My calculator is still stuck, it's not giving me the answer.
Yeah, press on. Yeah, just cancel it. Stop. Okay, let me show you. Let me show you how you solve a question. Yeah, everyone with me? All right, again, one more time. I told you that once you see numbers like this, don't keep them as big as you can see. Change them all to the simplest exponents that you can have. All right, so I have a 16.
The answer is D. It just.
Yeah, but this is, Naya, this is what we call the wasting time in the exam. Okay, you can't wait all of this with to your calculator to give it to you the answer. Okay, you can't. So you have to solve it by this way. 16 power 3x multiplied by 32, that's 16. 32 power x multiplied by 8 to the power of 3x. All of that equals to what? 4 power 6x multiplied by 32. That's a 4. 32 power 3x. All of that divided by 4. Okay, listen carefully. Now I'm gonna delete the 16, and I guess you know it. 16 is same as 2 power 4. Yes or not? 32, I will do it as 2 power 5. And the 8 is what?
Power 3.
2 power 3. And the 4 is what? 2 power 2. And the 32 is what? 2 power 5. And listen, at denominator, I have a 4. I'm going to delete the 4. I'm going to do it as 2 power 2. Okay, one more time. Now I have a power of power. I'm going to multiply the power. So it's going to be 2 power 12x multiplied by 2 to the power of 5x. You see what I'm doing? I'm multiplying the powers because it's actually one of the rules. Do you remember the rule? When you have an x power n and all of that to the power of m, this is when you have the answer as an x n multiplied by m. Rule number 9. You remember it? Multiplied by 2, 3 power 3x is going to be 2 power 9x. All of that equals to a fraction 2. Now I have a 2 power 6x is gonna be 12x. You can hear my voice, yes?
Yes.
Yeah. Multiplied by 2 power 15x. All of that 2 power 2. Okay, that's nice. Now, do I have the same bases? Yes, I do have the same bases. I'm gonna say it's gonna be the same base. I'm gonna add the powers. 12 plus 5 plus 9. 12 plus 5 plus 9 is gonna be 9, 11, 26 x equals 2. Now I can add the bases. I can do the same base and add the powers. 12 plus 15 is gonna be 27 x over 2 power 2x. 2 power 2, sorry. And now using here, I have a formula 2 power 26x. It is equals to 2 power 27x minus 2. Now I have the same basis. Yes, I do. So the power here is equal to the power there. So my final thing to do is 26x equals to 27x minus 2. I'm going to move 2 left. I'm going to move 26 right. That's going to be equals 27x minus 26x. That is equals to 2. And then x equals to 2. And that's how you get it.
When I put it into the calculator, it gave me like
-2.
No, it gave me continue equal.
It's continue. It's actually, listen, Yahya. Now, when you get like in the calculator some complicated equation like this is what we call the complicated equation, right? In the calculator, if you have a complicated equation, he's trying to approximate the answer. Okay. When you press continue, he's just trying to find the accurate answer, as accurate as they can. But first of all, like he's giving you some approximate answer. If you press continue, he's trying to give it to you more accurate answer, because it's complicated. Sometimes, I don't know, if you search more, you will find that there is some equations that you can't find accurate answer with it, but I can't find an appropriate answer, approximated answer. Do you understand?
Yes.
Like if you have an equation x plus 1 equals 5, this is what we call an equation with a certain answer. Like the answer is 4. There is no two of us that can say it's not 4. But there is an equations, okay? There is an equations so complicated that we can't find that specific answer. So this is what we say, that we will try to find an approximate answer. Okay?
Yes.
All right. I will try to give it to you homework for next time, guys. The homework is, if you download the file, the file on the platform, the homework is page. You see there is a pages down. Do you see the pages here? Okay. Do you see the pages?
Yes.
Page 41, 42 only. I know that there is an answers in the next pages. All right. I know that there is an answers in the next pages, but I want to see on notebook, and I'm going to ask you for this. Okay. So the homework for our next lesson, page 41 and 42, when in chapter 6. Okay, guys, your deadline to submit your answers is before our lesson. Next lesson is Wednesday, I guess. Wednesday, our lesson is going to be 5:30, so your deadline is 5. You have to submit your answers at 5. Assalamu alaikum, see you.
Wait, can you answer my questions?
Your questions, yeah, Tasneem.
Because I opened the PDF, but there
Just let me-
were no
let me start.
answers in that.